All right, AGS1, welcome back. Today we're going to be tackling 2.2, which is shh, please be discreet. That word discreet is definitely going to come up in this lesson, and I think it actually came up in 2.1. So, the toolbox at the top of your notes, please put the words discrete, continuous. I don't like these highlighters. Let's get a better color. Maybe this one. Discrete. Nope, that's worse. Okay, I'll just say them out loud. No, we'll highlight. Come on. Discrete, continuous, arithmetic, which once again has common differences in it, geometric, which has common ratios, and we are going to be building some explicit equations. So the first one, a library receives boxes of books. Each box is 8 books. So the first thing we're going to do is build a little table for the number of boxes here on the left, 0, 1, 2, 3, 6, and n. And then on the right, we are going to write the total number of books that the library would have. So if they have 0 boxes, they obviously have 0 books. Then if they have 1 box, that's 8 books. 2 boxes, 16 books. 3 boxes, 24 books. Then 6 boxes would be 6 times 8, which would be 48 books. So each time you're just multiplying the number of boxes times 8. So if you have n boxes, that means you have 8n books. So the explicit function would be f of n is just equal to an. Now normally you would put the plus the 0 day here, but notice that our 0 day is just 0. So it really doesn't make sense to put a plus 0 here. We don't really do that mathematically. So we'll just get rid of that and say it's just 8n. Now, we haven't really been using this word too much. Let's talk about what the domain of the function is. Before I talk about this actual problem, you guys, the domain is all the numbers that can go into the problem. It's your independent variable. This is your domain. Now, notice what kind of numbers you have in the domain. 0, 1, 2, 3, 4, 5, 6, all the way up to n. It's important to know that with the context of this problem, each domain number is a box, and you can't have like part of a box. You couldn't have 1.5 boxes or 1.2 boxes or something like that. So this is a discrete domain. So discrete, a way to think of that is that it's only counting numbers. Now, we don't really say counting numbers in math, so we're going to say that the domain of this problem is natural numbers. Now, natural numbers in math has its own fancy letter. I don't know if AGS1 gets into it, but I'll show you guys that this fancy n, natural numbers, is 0, 1, 2, 3, ... all the way up to infinity. Some people call them the counting numbers or the whole numbers, but remember that natural numbers include 0. So you can't really count 0 on your hand, but it is one of the natural numbers, just like we could have 0 boxes in that problem. Next up, we're going to look at electronic books, ebooks. So that same library has ebooks, but they download about 13 ebooks per hour. So just similar to the last problem, we're going to have our hours here on the left, and then I'm going to write how many total ebooks would be downloaded on the right. After 0 hours, we got 0 ebooks. Then we're doing, 13 an hour, so this would be 13. Now, 1.5 hours is interesting because you can download something for 1.5 hours, and then you would get 13, and then plus half of 13, which is what, 6.5? So 13 plus 6.5. That means there'd be 19.5 ebooks downloaded. You can have this because you can be like in the middle of downloading an ebook and that still counts. Like you have 19.5 ebooks downloaded. After 2 hours, you're going to have 26 ebooks. After 6 hours, 6 times 13, what is that? 70 something? Come on, Jolly. 78. So, ... 13. This is 78 ebooks. And then I'm just taking the number of hours and multiplying it by 13. So this would be 13n. Our explicit equation would be f of n is equal to 13n. Excuse me. Once again, no need to put the 0th day on the end because 0th day is 0. We're all good. Now, the domain is the interesting part of this problem because if you look at the domain here, this is time. It's hours. This does not have to count by whole numbers. You can be at 1.5 hours or 1.75 hours or 1.999 hours. So, this domain is continuous. I guess I shouldn't use the word data, but continuous domain. Because you can have all these numbers in between other numbers. We're going to say that the domain of this problem is real numbers. Remember that real numbers can be really almost any number you can think of. You know, it can be 1 or 1.1 or 5 halves or 1.23456. It really contains everything. The natural numbers back up here, these guys don't have any decimals or anything. It's only the big whole counting numbers of 0, 1, 2, 3, 4, all the way up. But real numbers has, you know, it has decimals in between. It has fractions. It has weird numbers like pi. I guess pi is not weird. It's just an example of like a real number that's kind of an unusual one. It's not weird, you guys. Let's move on. The last problem, a giant piece of paper is cut into 3 equal pieces each time it gets cut. So here, at 0 cuts, you still have the entire sheet of paper. But then when you make 1 cut, now when I say 1 cut, they are cutting those 2 lines through the paper. So 1 set of cuts is kind of what it is. Then we have 1, 2, 3 pieces. And then when you take those 3 and you make a second set of cuts, you get 1, 2, 3, 4, 5, 6, 7, 8, 9. If you were to sort of build up a little table for this, whoa, weird, where you put cuts on top and then pieces on the bottom. After 0 cuts, you have 1 piece of paper. After 1 set of cuts, you have 3 pieces of paper. And after 2 set of cuts, you have 9 pieces of paper. Do you guys see the pattern here? That if I was to make another set of cuts, like, you know, if you take those 9 pieces and then you go, this would be the 3rd set of cuts. That each of those 9 gets split into 3. So you're going to have 27 after the 3rd cut. If you guys look at this data, 1, 3, 9, 27, it's growing geometrically. It's getting multiplied each time. So the way we can write the geometric equation is day 0, or 0 cuts, times the geometric ratio, which is 3, to the power of n. Yeah, so each time it gets multiplied by another 3, so there's another 3 there. You guys, the domain on this guy is discrete again. Discrete, it's discrete because you can't have like half a cut. You got to do a whole set of cuts each time. You can't have 1.5 set of cuts. So, it's counting numbers again. So, you would say that the domain is natural numbers, which, once again, if you ever get into like once you get into an IB class, that's going to be fancy capital M. You guys, there is one more problem that has to do with dog medicine or something like that. That's like each time you lose 20% of the medicine. That's very similar to a problem we did in 2.1. So I want you guys to try working on that one on your own. Please message Mr. Jolly, DM me, or Miss McNeely if you have questions on that one.